So now the second instruction in this data transfer copying group of the instruction is MVI. So this MVI means move or copy 8 bit of immediate data from source to destination. So this destination might be this register or memory, but source will be always 8 bit of data. So let's say this we can understand their opcode is MVI and their operand is register comma 8 bit of data, 8 bit data, or this can be memory comma 8 bit of data. So how we can understand this? We can understand this with the example. For example, MVI B comma 7FH, and the second variant we can take it here as a MVI M means memory location, which is pointed by HL register pair comma 8 bit of immediate data. So I can say it here as a FFH. So the function for this first instruction is it will copy this 7FH as a immediate data into the processor B register here, and by that way it is going to complete the execution of this instruction. So first of all we should find here their size in terms of bytes. So as I explained earlier also, this MVIB is having their 8 bit of code, so that is called their opcode, and this 7FH is called here as a 8 bit of immediate data. So this I denotes here as a immediate data and MB denotes here for moving or copying of this immediate data into their destination register or memory. In this instruction MVI M comma FFH, so what will happen here? This will copy the immediate data as a FFH into the memory location which is pointed out or whose address is holded by HL register pair. So now first of all we need to find out their size in terms of bytes. So let's say this MVI-B is having the hex code, equivalent hex code as a 06H, and this is their 8 bit of immediate data. So let's say it is stored in some memory location. I am taking the starting memory location for this instruction as a 1000H. So at 1000H, MVI-B opcode, their equivalent hex code is 06H is stored, and at the next location at 1001H it is having 7FH. So as we know that whenever we are going to write a program or executing an instruction, before execution by the processor it must have to store into this memory part first, and after pressing the execute button by the kit of this microprocessor we are going to fetching this memory, and first as a opcode, then as a operand, and after then processor is going to execute this instruction completely. So here how many byte it is required in size, like bytes it is required as a size is here 2 byte, because this is 1 byte, this is another byte. So for this instruction also this MVI M is having their equivalent hex code, and that is in terms of 8 bits in terms of binary, and the another byte is as a immediate data FFH. So as a size in bytes it is also required 2 bytes of the memory to store this program or this instruction. So here now how many machine cycle it will take, that we need to understand first. For this MVI-M, I am taking their starting address is at 1002H, and here for this MVI-M their hex code is 36H. So this is stored here as a 36H, and at 1003H their data is FFH. So here one thing I would like to say you that no need to remember about this MVI-B code or this MVI-M code, because as per the requirement in the exam it must be provided as a data sheet or as a part of the information in the question itself. So just for your better understanding I am taking this data from the textbook to understand this instruction in the better way. So now we'll talk about that machine cycle for the first variant as a MVI B, 7FH. So once this MVI B, this 06H as a equivalent hex code, it is coming from memory to this microprocessor. It is coming here by the use of that data lines. Then after decoding and execution of this, processor is knowing that the next byte, the next immediate byte will be the operand for this instruction, and that will copying into the processor register as a B register. So first of all, it will fetch here as a opcode 06H, and after performing the decoding and execution of this opcode fetch, it is knowing that next byte of this immediate address will be their operand, which is going to move or copying into B register. So ultimately, by the execution of this instruction, microprocessor is going to access this memory two times. One is called as a opcode fetch operation, as a reading of this 06H as a opcode, and then the second operation is memory read operation, so which is equivalent to reading of this immediate operand as a 7FH. So their machine cycle will be 2 and their operation will be opcode fetch plus memory read. And I had explained earlier that in general for almost all the instruction except few instruction, for opcode fetch operation it is required 4 T state. So it will take here 4 T state for opcode fetch operation, and for this memory reading operation it will take 3 T state. So 4 plus 3, it will take total T state as a 7 T state to execute this instruction as a MVI B, 7FH, or it will take 7 clock period or 7 clock cycle for the complete execution of this instruction as a MVI B, 7FH. Now we'll come to this second variant as a MVI M, FFH. So as I had explained, this will take 2 bytes to store this instruction into the memory. So the first byte is stored as a 36H, and the second byte it is stored here as a FFH, as a immediate data. So here how it will operate? First of all, it will perform this opcode fetch operation of this 36H. So after decoding and execution of this 36H by the microprocessor, it is understanding that the immediate data must have to stored into the memory location which is pointed by this HL register pair. So first of all, it will perform opcode fetch operation for this MVI M as a 36H. After then, it is going to read this FFH data from the memory 1003H, and then it is going to store. Where it is going to store? In the memory location which is pointed by this HL register pair. So for example, let's say this HL is having the content as a 2002H. So first machine cycle will be opcode fetch as a MVI M, whose equivalent hex code is 36H. So here that is called opcode fetch operation. After then, it is going to read this immediate data, that is FFH. So this is called here as a memory read operation, and then where it is going to copy. So first of all, processor should know where have to copy. So processor is knowing by extracting the content of HL as a 2002H. So wherever it is 2002H in the memory location, at that location it is going to store this data as a FFH. So before moving this FFH data to this location, because FFH is available at 1003H, but processor is not knowing where to move. So first of all, this data must have to move into the processor, and after then processor will read this content of the HL, so that this HL content will be that memory address where this data FFH has to move. So first machine cycle is opcode fetch, second machine cycle is reading this immediate data as a opcode fetch, and the third operation, it is going to store this content as a immediate data FFH into the memory location which is pointed by this HL register pair content as a 2002H. So at this 2002H, it is going to store this 8 bit of immediate data as a FFH. So this third operation is called, it is storing this at 2002H by the processor. So this is called memory write operation. This is called here memory write operation. So total number of machine cycle required for this instruction as a MVI M,FFH is 3 machine cycle, and as we know that for the opcode fetch operation it will take 4 T state, for memory read it will take 3 T state, for memory write it will take 3 T state. So total number of T state required will be 10 T state for the complete execution of this instruction as a MVI M,FFH. So I hope you understand this, both the variant of this MVI instruction, how to find out their size in terms of byte, their functionality. Based on the functionality, we can find out their number of machine cycle. Based on the machine cycle, we can easily find out their number of T state, and based on this T state, we can easily find out the execution time for this particular instruction. So next we will see as a third instruction for this data transfer comping instruction, that is called LXI.